Hi, my name is Jared Gull. I work for Juniper Networks in the Education Services Department, and today I'll be sharing a learning byte on troubleshooting tools for wireless LAN networks. In this presentation, before we get into the troubleshooting tools section, we'll talk briefly about some WLAN troubleshooting essentials. Specifically, we'll look at a sample network and discuss and describe some of the components and communication requirements therein. And then we'll provide a basic approach to troubleshooting a WLAN network issue, essentially a flow chart describing some of the items to check and whatnot. So first and foremost, it's critical that you understand your network, you understand the components, how those components interact, the communications required therein, and really just what the components are responsible for, the roles and responsibilities of those various components. Here we have a sample topology, and it illustrates the various components, including wireless clients, the WLA or access point, the controller, the various servers including DHCP server, DNS server, radius server, external user database server, certificate authority server, and the supporting layer 2, layer 3 network components. So understanding all of these elements and what they do and how they interact one with another is key. You can find a lot of information about this in our courseware. We do have a couple of training courses that cover wireless LAN networks, so if you're interested, check into that. As far as a basic approach to troubleshooting, as an administrator, you'll likely receive a report from end users that maybe the network's not accessible or they can't access their resources or something to that effect. So when working in a wireless network, one of the first things you'll probably want to do in that situation is verify that the service is actually available, verifying that the SSID is being advertised. If it's not, you'll want to look into the WLA or the access point, verify that it has power, that it has received an IP address, that it can communicate with and receive configuration from a controller in the network. If the service is available, then you'll have to troubleshoot the service itself, verify that the clients can authenticate. If they can, you'll need to look into authorization issues, verify that the user's VLAN and any other attributes are properly applied through the radius and user database. Verifying that the radius receives requests. If the user can authenticate, you'll want to look into the radius components there and verify that radius is receiving requests from the controller, and if it is, then it's likely a radius issue, so you have to focus in on troubleshooting the radius server. If not, then you'll want to look at the client and verify that the client's configured correctly. If the client is configured correctly, then it might be an issue on the controller. Maybe the controller needs some configuration changes, or perhaps if not, it's a client issue, so user credentials or a setting on the wireless card or something to that effect. So again, a basic troubleshooting flow. Your approach will likely vary in some way, but this provides some basic structure when approaching troubleshooting. As far as troubleshooting tools go, any standard troubleshooting tools you would use in a wired network are applicable here as well. That includes utilities such as ping and traceroute and those types of utilities. You can also use protocol analyzers such as Wireshark. In a wireless situation, you can also use WLAN sniffers, the wireless client drivers, and other software, purpose-built software such as Insider to aid in troubleshooting from a client's perspective. Outside of the standard troubleshooting tools, WLAN solution provided by Juniper also includes a number of troubleshooting tools, such as the command line interface on the WLCs or the controllers. The various commands, CLI commands and outputs can provide a wealth of information that can lead you to identifying issues and fixing those issues. You can also make use of trace, which is a debug function that you can set up for a specific process or area, as well as RFC compliant syslogs, which can be viewed locally on the controller itself through the CLI, or can be exported to a remote server for analysis. In addition to these command line services and the commands and outputs, there are a couple of utilities, RF Snoop, Radius Ping, and RF Ping. These can provide additional insight and information that may help you pin down an issue and get that issue fixed. We'll focus in on a couple of these, specifically Radius Ping or Rad Ping and RF Ping. In the next portion here, we'll have a couple demonstrations. So the first demonstration, we'll focus on Radius Ping. This is a utility run from the controller that allows you to verify authentication, communication between the controller, which is a Radius client, and the Radius server itself, as well as verifying some authentication for a user. So here we have the basic structure. The Radius server in our example is 10.2.10.14.9. It's on the same subnet as the controller, and our controller is WLC1 in this example. So using the rad ping command, you're going to specify either a Radius group or a server. In our example, we have a specific server defined, which has been named MyRadius server. That MyRadius server device is associated with the 10.2.10.14.9 server illustrated in the diagram. So then you specify a request type. There are a number of different request types you could potentially use with this command. In our example, we're focusing in on authentication instead of accounting. So we're going to use the authentication option, and then you're going to specify a user, its password, and if you have MS Chap involved, you'll specify that as well at the end. In this first example, I want to use a invalid user account, so I'm going to specify a user of blah and a password of blah, and I do have MS Chap v2 in play here, so we're going to use that at the end of the command. And here in this example, you can see that from the controller, an authentication request was sent to the MyRadius server at that address using that port. We have actually received a response. In this case, we've received an access reject response from the server, which means our communication is fine. It's just that the user credential parameters were not accepted, not valid. And you can also see kind of the time frame involved there on the response. So that's the access reject response. Now I want to show you an access accept response here. We'll swap out the user credentials with some valid credentials, in this case EMPL-8 and a password of I forgot. And the same basic process, we send out that authentication request message to the server. In this case, we've received an access accept from the server, and here you can see the returned attribute of employee. So, okay, and that concludes that first demonstration. The next utility, troubleshooting tool I'd like to demonstrate is the RF ping utility. So the RF ping utility really assesses the connection between the client and the access point. And this will give you some environmental insight to the environment, and just some of the details such as signal strength and signal to noise ratio details. So here we have a single client with a session to the access point, which is controlled by WLC1. So we'll go back to our WLC1 device. With the RF ping utility, there is a piece of information you're going to need to use this utility. You can identify the MAC address of the wireless client or the session ID for the session that client is currently participating in. So to identify those pieces of information, you'll need to use the show sessions network command. This will show you the session ID. So in my example, I only have a single session that's associated with this user here, the student 80 user. The session ID value is 4. You see the type, the IP address, the VLAN, and the APN radio details for that session. So there's our session ID. To identify the MAC address of that client, the student 80 client device, you use the show sessions network command with some additional operators. So session ID and then the session ID value of 4 in this example. So with that command you get actually quite a bit more information. You'll get some statistical information down below that we won't focus in on, but a number of other details shown here. One of those pieces of information is the MAC address. So this MAC address shown here is the MAC address of the wireless client that's participating in that session. So we'll quit that, and going back to the RF ping command, in this example we'll just use the session ID to keep it simple, and we know that the session ID is 4 from our previous commands there. So here we, after issuing the command, we see that 20 layer 2 packets have been sent out from the access point. 20 packets have been received from the client. We see that the signal strength is -35, which is a very good signal strength, which makes sense since this is a lab environment. We've got the access point and client in very close proximity. We also have a signal strength of or signal to noise ratio of 59, which is a very good value. Really anything above 25, 30 is a reasonably good ratio value there. And then you have some round trip time values as well. That concludes our second demonstration using the RF ping utility, and that also concludes our Learning Byte for today. I hope you've learned something and enjoyed yourself, and please tune in for more Learning Bytes in the future. Thank you.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.